process that Matthias was talking about to design our robot. There were many different ways we could accomplish our goal, and our goal was to build a modular, multimedia moving robot. For instance, there was different ways we could get the robot to move. There were different shapes we could make the frame. There were different motor configurations, and there were different materials that we could use. So to narrow down these options, we did a lot of analysis, and we prototyped using VEX. For those of you that don't know, VEX is it's similar to an erector set with metal parts and microcontrollers and motors. And next slide. And we used this VEX prototype to test different frame shapes, wheel placements, drivetrains, and safety sensors. In the end, we decided on a symmetrical frame with a three-wheel design that used differential tank steering because it was simple. For safety, we used a lot of redundancy in our system, and we also used sensors that it could detect its environment and avoid collisions and flipping. And now I'll let Dorsey talk about this.
Hi, I'm Dorsey Shirazi. My major is biomedical engineering, and it's my third year at IVC. After we built and test our VEX prototype, we decided to have a three-wheels design, and we chose this design because it gives us this opportunity to move the robots in the same place. And also, further evaluation shows our Omni wheels could turn better. And also for the coverage and the sensor could also be extended. And the two-way communication system, it was a good idea to avoid the communication bugs. The picture we have here is a complete prototype. And next slide, please. After we finished with the VEX, we built a full-scale robot, and we designed that with the SolidWorks. And the design, it was the similar shape of our VEX, and also, but the difference was it has more space for the batteries and also the addition hardware. And also it has more powerful controls to avoid the issues which we have with the VEX. Our robot will use industry standard software to make it easier for our future students to use the design and improve our design and to figure out what we did. We're going back to you.
Here's some images within the building process of our design cycle. Brett McKim was generous enough to lend his expertise and tools for us to get this done. We have the cutting of the square tubing. Here I am scoring down the corners for the welding. We have a pre-assembled chassis with the chassis schematics right here. And we had a professional welder come in and help us put our pieces into a solid structure. With that said, we have the unveiling of our robot, which is in progress right now. This is it right here. So we have a 6061 T4 grade aluminum welded chassis. We have dual parallax motors and motor controllers. This is all controlled by dual Arduino microprocessors, which is essentially the brains of the whole robot. And with that, we have implemented a Wi-Fi communication system, which allows us to connect over Wi-Fi, not too different from what you have in everyday home. And this is it right here. So I'll hand it off to Kyle for our conclusion.
Okay, thank you, Matthias. I'm just going to finish up with a few final thoughts. First, what's really great about our robotics program is it serves as an excellent educational platform. Once we have our actual robot constructed, we can add the different modules that I mentioned earlier on top of it. So that way, in the future, once we finish our filming rig, we can actually take the filming rig off, and students in the future can create their own new ideas and put them down on top of the robot and use this as a good platform to work on. Right now, as I mentioned, we have the current 5 phases. We're still on phase 1, which is completing the base. But we plan to complete the filming rig and the first module on top of the robot in the next 2 years. It's also really nice that we have this system because it's very easy to demo. We can bring it to a lot of events or classes or pretty much any other venue. We can set it up very quickly, and we can demonstrate and also kind of share experiences that we've had in the construction of a robot, as well as what the robot can actually do at that time. There's also a lot of program benefits. What a lot of people like about our program is that it's very hands-on. They can use a lot of information they learned here at the IVC courses, and they can kind of utilize everything all together in such a project. There's also a lot of networking opportunities. For example, the pictures to the right is from an expo that we recently attended earlier this year. And at this expo, we demoed not this robot, but our previous prototype robot, since that's what we're working on at the time. And at these events, it's really nice because we can meet people within the industry, as well as kind of get a feel for what the general public has to say about what we're doing. So right now we're working on completing phase 1. That's just kind of a rendered image that we generated as a possible module for our robot. So we're going to complete this within the year, our robotic base. We're going to attempt to recruit more members, and also we want to try to continue our public outreach. We want to be able to bring this to different places and classes and demo it for people. And it's great because we're also trying to increase STEM awareness with our project. And let me see. I think that is, for the most part, our presentation. Another thing that we also want to get is try and gain more faculty support in general. We like the success that we've had so far with our work, and if we can get more faculty behind it, that would help us greatly. And before we conclude, I just want to thank a few people that have helped kind of get the program going. For starters, we had David Gatewood, who helped us a lot in providing us with lots of resources and his generous support. We've also had Kumar and Mathebotics, who has assisted us in pretty much jump-starting the robotic program here. We also had Brett McKim, who provided us with his equipment and knowledge and assisted us in the fabrication of our chassis. We've also had Professor Bilkner White, who is very nicely filming us at the moment, who's the Applied Science Engineering faculty advisor, so we thank her for her support. We also have had Matt Suarez, who is also here in the audience, and the ATEP staff, who have generously provided their facilities and also equipment for them, or for us to use. We have also had Matt Walken from IVC, who has helped us with his knowledge and resources, and also I'd like to thank Jack for pretty much being to help us throughout the entire project. So that concludes our presentation. If anyone has any questions, we'd be more than welcome to take them at this time.